Okay, we're going to start this video by grading 10-5. It's out of 57 points. Please make sure that you are writing down what you took off points for. So if it's sig figs, it's -1/2, right? If it's the answer, write -1/2, and then write what the correct answer is. So you're supposed to circle the empirical formulas, so you should have 4 of them circled. Those are each worth a ½ point. Which one of these formulas in problem 1 all have the same empirical formula? It'd be C6N10H4 and C9N15H6. I would know that for the test, okay? Number 3, you're finding the empirical formula. So you have find the mass that is converted to moles. So these are the moles. So it's ½ point for the answer, ½ point for sig figs. Showing that you divided by small is worth 1 point. Then I do have to multiply by 2 to get the empirical formula to make the number whole. It's V2O5, 1 point. 4, the only work I need to see is that you divided, right, by the molar masses of the empirical in the denominator and the molar mass of the compound in the numerator. So 90.0 divided by 30.0 is 3. So I multiply it by 3. That's the X factor. The final answer is C3H6O3. For B, you have to show that ratio again of the molar masses. 146.0 divided by 73.0 gives you 2. Multiplying by the empirical formula, you get C6H10O4. For the next problem, 5, you have 3 elements, and in this one, you still are going to find the moles. So for carbon, I found 3.33, 1 point for the work of each one of these going grams to moles. This one is 6.7. This one, if you have 3 sig figs, you would mark off a ½ for the sig figs. So I'll be looking for that when I collect your papers. 53.5 divided by 16.0 is 3.34. 1 point for showing that you divided by all of these to get for the small. The answer is CH2O. For the empirical, now you still have to find the molecular. For the molecular, I would take 60.0 divided by 30.0. That's the molar mass of the molecular compound divided by the empirical. You get a factor of 2. So it's 1 point for numerator, denominator, 1 point for the X factor. The final molecular formula is C2H4O2. Next page, we're looking at, this is a problem that looks just like the one that I said is a test question on the notes, right? So you have to find the molecular formula, but you don't have the empirical formula. So the empirical formula, you have to solve for moles, so 0.500 moles of N, 0.750 moles of O. Don't forget to divide by small first. So it's 1 point for dividing by small. You got to multiply by 2 to make whole. You get N2O3. Then what you're going to do is take the molar mass of the compound divided by the empirical. 1 point for each one of these. You get 2. 2 times the empirical formula is N4O6. That's worth 1 point. So now we're looking at this problem here, worth 11 points. You're going to convert the grams to moles. Remember, you just changed the percent sign to grams. You get 7.69 here. Check your sig figs here. Should just be 7.8. Divided by small is worth 1 point. You get 1.00, 1.0. That's CH. You got to find the X factor, molar mass of the compound divided by the empirical. That's worth 1 point each. The X factor is 8, so it's CH8 worth 1 point. The entire thing is worth 57 points. Make sure you have the score on the front, and then I will collect that from you the next time I see you. Now, we're looking at the notes. For the notes, we are going to look at page 8. You need your notes. You need a periodic table. You need something to write with and a calculator. So a hydrate. Hydrate is the last thing we have to learn. Hydrates are an application of empirical formulas. So hydrate is a compound that has a specific number of water molecules bound to its atoms. So here's my hydrate. And what I can do is I can add heat, and if I add heat, the anhydrous will be separated from the water. The name of this anhydrous, the name of this anhydrous is copper 2 sulfate. The name of this hydrate is copper Roman numeral 2 sulfate pentahydrate. So copper Roman numeral 2 sulfate pentahydrate. And here is a list of a bunch of hydrates. What I want you to notice is that all of the formula units have a 1 in front. So you can't multiply to make whole on these, all right? But the numbers are going to be different for the water molecules. So how do I name them? And how do I write formulas? For hydrate formulas, right? The number of water molecules, N, so that's something that you got to know. We're going to express the water molecules by the letter N. Associated with each formula unit of a compound is written following a dot. So for the name, you write the name of the salt compound followed by the prefix of the number of water molecules in the word hydrate. So 1 is mono, 2 is di, 3 tri, 4 tetra, 5 penta, hexa, hepta, octa, 9 is nona, 10 is deca, just like the Greek prefixes in molecular nomenclature. All right. So for example, if I have Na2CO3.10H2O, I name this ionic compound. Na is a metal. It's not a transition metal, so the name is sodium. And then CO3, I look at my polyatomic ion list, and that is CO3 2-, right, which is carbonate. So carbonate. 10, the prefix is deca, so it's decahydrate. All right, now we're going to practice. So a mass of 2.50 grams of blue hydrated copper 2 sulfate is placed in a crucible and heated. After heating, I only end up with 1.59 grams of anhydrous copper 2 sulfate. What is the value of N? Remember, N is the number of water molecules. What's the name? What's the formula? So the mass of my hydrate. My mass of my hydrate is 2.50. So I'm going to put 2.50 grams of my hydrate. My anhydrous is 1.59. So then what is my mass of water? Well, remember, when we heat the crucible with the hydrate, it removes the water. So if I want to find the water, I subtract these two. So I'm going to take 2.50 grams minus 1.59 grams. And I get 0.91 grams. And I'm going to keep my leftmost uncertainty. So that would be 2 decimal places. And that would be H2O. After you find your mass of water, I would encourage you to cross out the hydrate because you don't need that number anymore. So now what I'm going to do is convert to moles. These are the two that I have. So I need to convert to the moles of the anhydrous and water. This number goes here. So I'm going to take 1.59 grams of CuSO4. And remember, we're trying to find moles. Find the mass, convert to moles. I'm going to do the same thing with the water. The water goes here, though. 0.91 grams of H2O. So we're going to find moles of both. So I'm going to put grams of CuSO4 down here. Mole of CuSO4 up here. One goes with the molar mass here. I'm going to take 63.5, right, plus the molar mass of sulfur. When I add the molar mass of sulfur and oxygen, the oxygen is going to give me 4 times 16, right? The sulfur was 32.1. So then when I add those all up, I get 159.6. Now remember, sig figs are what's going to get students, so make sure that you are writing your sig figs, figuring them out. So this is 1, 2, 3, 3 sig figs. Here, 1, 2, 3, 4, 4 sig figs. So I'm going to round to 3 sig figs. So when I put this in my calculator, I get 0.000996240.6. Now, be careful because I can only have 3 sig figs. 1, 2, these 3 do not count, right? Those are leading zeros. So I can't count till here. So I have 0.00996 where these zeros don't count. Grams of H2O, mole of H2O. I'm going to get 1 goes with the mole. Molar mass of water is 18.0. So then I get I put this in my calculator. I'm going to count my sig figs. That 0 doesn't count. 2 sig figs, 3 sig figs. I'm going to round to 2 sig figs. But my calculator gives me 0.05055. So then I need 2 sig figs. These zeros can't count. 1, 2, look at the neighbor. So this number is 0.051. Remember, these zeros don't count. So with hydrates, we divide by small and we never multiply, because remember, that number in front always has to be 1. The only way that can happen is if I never, ever multiply hydrates. So I'm going to write it like a formula. So I have my CuSO4. And I have my H2O. My mole amounts are 0.00996 and 0.051. I'm going to divide by small, which is always going to be the formula units, mole amount. I have to show what those values are. This would be 1.00. This one is 2 sig figs, 3 sig figs. I got to round to 2 sig figs. That gives me 5.1. I can't multiply hydrates. So that means that N equals 5. There's 5 H2O molecules. So now I'm going to write my final answer here. N, number of water molecules, is 5. The name, CuSO4, is copper 2 sulfate. The problem actually gave me the name of the formula unit, copper, Roman numeral 2, sulfate. 5 is pentahydrate. The formula now here would be CuSO4, and remember, it's a dot followed by the number of N, so in this case 5, H2O. And that's my final answer. So now, this is what you need to know how to do for the pre-lab and the lab. I would look at this for the pre-lab, okay? A hydrate of copper 2 nitrate was heated, and after the water was driven off, anhydrous CuNO3 remained. Determine the value of N, the number of water molecules, the name for this hydrate, and the formula for the hydrate. So they give me the mass of the crucible and lid. Why do they give me the mass of the crucible and lid? because you can't just heat up this hydrate in your hand. You have to contain it. So we have to account that there's a mass of the crucible and lid. So if I just want the mass of the hydrate, all right, I'm going to take this mass and I'm going to subtract the crucible and lid. So I'm going to take 37.28 grams minus 32.28 grams. So when I subtract those, I get 5 in my calculator. But I am smarter than my calculator, and I know that leftmost uncertainty goes to 2 decimal places. So it's 5.00 grams of the hydrate. So now, if I want the anhydrous is this one. So I'm going to use the anhydrous with the crucible and lid and subtract the crucible and lid from it. So I have 36.18 grams minus 32.28 grams. When I subtract those in my calculator, I get 3.9 grams. And this is of the anhydrous. What's the anhydrous? It's just the formula unit. So it's CuNO3 2. So I'm going to label that. But remember, I'm smarter than my calculator, and I got to have 2 decimal places because that's my leftmost uncertainty. So then now, the water. You take the hydrate minus the anhydrous to get the water. So I'm going to subtract these two now. So I take 5.00 grams minus 3.90 grams. And when I do that, I get 1.1 in my calculator. Once again, I'm smarter than my calculator. I'm going to subtract, but I have to keep my leftmost uncertainty, so I keep that 0 of H2O. Remember, once I find this, right, I cross this out. That's what happens. A lot of students want to use the hydrate. This is the anhydrous. So I need this number here, right? This number here. So I'm going to take 3.90 grams of CuNO3 2, and the water here is 1.10 grams of H2O. Now, what I would like for you to do is to go ahead and finish this problem. Find the moles, right? Divide by small, never multiply hydrates, and then we're going to check to see if you get the right answer. So I would pause the video and see if you get the answer that I get in my presentation here. Now we're back. So once again, this is step 1, finding the mass. So we did that. Remember, we're going to cross out the hydrate, so we only find the mole amount of the anhydrous and the water. So I start with my anhydrous, set up my workspace. Hopefully you got 187.5 for the molar mass of copper 2 nitrate. I got 0.0208 with 3 sig figs. Now I'm going to do the water. Divide by 18.0, that's the molar mass of water, and I get 0.0611. Those zeros don't count. Write it like a formula. And now I have to divide by small, which is always going to be the first number here. So I divide by 0.0208. I got to show what those numbers are, 1.00 and 2.94. 2.94 is close enough to 3 because I can't multiply hydrates anyways. So N equals 3. And the name of this, right? According to the problem, it's copper 2 nitrate. So I put copper 2 nitrate. And then 3, the prefix for 3 is trihydrate. For the formula, I'm going to write CuNO3 in parentheses 2 dot and then 3H2O. And that is my answer. Okay. You want to look at Google Classroom for what's your homework. You are going to be doing the pre-lab. So I want to show you what the pre-lab looks like. This is the pre-lab here. You're going to fill out your purpose. You're going to make sure that you have your pre-lab questions filled out, and you're going to give me the names of these and then figure out the molar masses. You're going to continue on the back and do this problem. This problem here looks a lot like this one. Make sure to cross out the hydrate after you find the water and only use the anhydrous and the water to figure out the name and formula of the hydrate.